isosceles. So our right isosceles triangle, and label everything you know about it. Today is about right isosceles triangles. They are the star of the show. Sometimes call them rhisosceles triangles, like a rhinoceros, because it's like shoving the two words together. That's what you can title your notes, rhisosceles triangles. Spelling is questionable. Hopefully your picture looks something like this. Hopefully you have a triangle with a right angle with congruent side markings. And then hopefully you label these angles if the sides are congruent and the angles opposite are congruent. And then you might have gone as far as to find the exact measure of the angles. We know a triangle has 180 degrees. Subtract 90, you've got 90 left. You have to split it evenly between the last two angles. And so we don't just know that they're congruent, we know exactly what they equal. So yes, today we're learning about 45, 45, 90 triangles, where 45, 45, and 90 are the measures of the angles. So if a triangle is right in isosceles, then its angles are 45, 45, 90. Converse, if a triangle has angles 45, 45, 90, then it is right and isosceles. Okay, take a look at these patterns. What is going on here? What do you notice? The odd one out is the hypotenuse. So these are what kind of triangles? They're right, and they're isosceles, yeah. So we've got elephant, elephant, elephant bird. Pineapple, pineapple, pineapple butterfly. Flower, flower, flower tree branch. Crying emoji, crying emoji, crying emoji monkey. Okay, you like the pineapple one. All right, let's see how this relates to today's lesson. This is a pattern. And this pattern is not a coincidence. It happens every time we have right and isosceles triangles. Not yet. Yes. Do Pythagorean theorem, solve for the hypotenuse, and leave it as a simplified radical. All right, what was the hypotenuse length for A, triangle A? As a simplified radical. Good. So this side is 5. This side is 5 root 2. B. 9. This side is 3. This side is 3 root 2. Okay, just getting a little messy. C. Good. This side is 1. This side is technically 1 root 2, although we don't write the 1 because it's understood. And Sharon. Good. This side is x. This side is x root 2. Oh my goodness, what do you see? Pineapple, pineapple, pineapple butterfly. Right? 5, 5, 5 root 2. 3, 3, 3 root 2. 1, 1, 1 root 2. X, X, X root 2. This is not a coincidence. It happens every time. It's a pattern for 45, 45, 90 triangles. So I want you to write it down. It's not really a theorem, but it is a pattern that happens every time, and it's a fabulous shortcut. So write this down in your notes. This is today's lesson, all on this slide. Could have just shown you this slide and lesson over. But of course, we'll practice next. Okay, let's move on. X, X, X root 2. A wonderful shortcut that allows you to not have to do all the work you did to find the missing hypotenuse in these examples when you added them and then you factor treed, square root of 50 or whatever. So let's try out our new rule. Sorry, I'm not going to show you the clip. Try our new rule on some examples, starting easy. 9, 9 root 2, right? So we can find all of the missing sides, the hypotenuse being 9 times radical 2. No math, no work shown, right? Next one. Something, something, 2 root 2. Yeah, it's just the coefficient of root 2. 2, 2, solving problems so quickly now. Try this one. The answer is not 5. This one follows the same pattern. No one said that x had to be an integer, that x had to be a whole number. It follows the same pattern. There's nothing wrong with the sides being a radical. 5 root 2, 5 root 2, 5 root 2, root 2. X, x, x root 2. This is our x, and our x root 2. Now we need to simplify. That's why we spent days learning how to simplify radicals. Square root 2 times square root of 2 is actually just 2. So the length of the hypotenuse is 10. If you want to write square root of 4 first, you can. But we know that 4 is a perfect square. So we never leave our answer like this. You would not get full credit on the quiz. The simplified answer is 10. All right, next example. Good. 2 root 3, 2 root 3, 2 root 3, root 2. Not our final answer, of course. We learned how to multiply radicals. We learned when we add, the radicals have to be alike. They have to match. But when we multiply, we're allowed to multiply any two radicals together. 2 root 6 is the length of the hypotenuse. Okay, now let's get a little bit deeper. Write this example down and do not type the answer yet. This one's a little bit different because our hypotenuse is not something root 2. It's like not following the rules. What are you doing to its hypotenuse? So what I want you to do until you get used to it, if you need to, I want you to write the rule on the picture. X, x, x root 2. So I'm looking for x. And I have x root 2. Really, you can treat this as an equation, and you can just solve it. X root 2 is 5 root 6. Well, how do I solve for x? We know how to solve. The opposite of multiplying by root 2 is dividing by root 2. So to solve this problem, you take your hypotenuse and you divide by root 2. Are you allowed to divide those? Square root of 6 by square root of 2? Absolutely. So I'll just show extra words just in case. These cancel and get 3. So our leg is 5 root 3. 5 root 3. 5 root 3. You can always check your answer if you're scared you did something wrong. So the pattern should be 5 root 3. 5 root 3. 5 root 3 root 2. Okay, is that the answer? Does that match that? Oh, thank goodness. They match. I checked my answer. Move on. Cool. Try that one. Okay, so if you don't know where to start, you can always write your pattern on the picture. I don't know where to start, so I'm going to write x, x, x root 2. We are always safe with using our pattern. X, x, x root 2. 6 is not our x. It's our x root 2. But remember, when we don't know what to do, we can just solve this as if we're solving an equation. So, the way to isolate x, the way to solve for x, is to divide both sides by root 2. And then this can't be our answer. This is x. But it's not a simplified answer. We can't ever stop there. So we have a radical in the denominator. So we have to rationalize the denominator. Multiply across the bottom. Square root 2 times square root 2 is 2. 6 times square root 2. Oh, not the final answer yet. Got too excited. There we go. We can simplify one step more. 6 divided by 2 is 3. 3 root 2. Not a coincidence that these are both, the coefficient is half of the hypotenuse. So I don't want you to memorize this trick, but I wanted you to know that that does happen every time. It's not a coincidence. So if that was 18, if this was 70, You really don't have to do all that work every time. When you divide it by root 2 and you rationalize the denominator, yes, you'll get 9 root 2. When you divide by root 2 and rationalize the denominator, yes, you will get 35 root 2. That was not a coincidence that 6 and 3 are half and double. Okay? Okay. Let's do some more. There's 3 examples left. Find the length of the hypotenuse. So like I said, this one, we didn't make the math intense on this one. So, yeah, we do need to be careful. We need to look at our picture and see what we notice. I noticed that this has a length of 7, and because of the properties of a rectangle, I noticed that that would also have a length of 7. Well, if I've got 19 to use, I've used up 7. That means I have 12 inches remaining. Is this a 45, 45, 90 triangle? Yes, triangle sum theorem means that other angle is also 45. Oh, cool. So now we can just do our pattern. 12, 12, 12 root 2 inches. Final answer. Try this one. 2 examples left. Ooh, find the perimeter of ABCD, which is a parallelogram. The scaling of the picture is a little weird. It's not, the sides that are congruent don't really look congruent, so just be careful there. If this is 45, and it's across from 3 root 2, then what's that angle if it's also across from 3 root 2? 45, right? If the sides are congruent, then the angles opposite are congruent, making this a right angle. 3 root 2, 3 root 2, 3 root 2, root 2. What's 3 root 2, root 2? 6. Yep, we did that earlier in the lesson today. It's 3 times 2. Now be careful. Never add an integer to a radical. Never add an integer to a radical. Those are not like terms. So if I was adding this together, I wouldn't normally write it in that order, but I'm trying to make a point. I am only allowed to add my like terms. I can add my integers. I can add my radicals. But I can never combine the 12 and the 6. Can't tell you how many students will write 18 root 2 as their final answer. And then all that work was for nothing. Because it is illegal to add those together in algebra because they're not like terms. It's like adding an x and a y together. Careful. Last problem of the day. I spy a Pythagorean triple. Do you see one? No, I don't. Never mind. The 8's in the wrong spot. All right, let's get started. Let's call this A and let's call this B. Let's look for A first, Pythagorean theorem. Well, that's an A. Kind of wish it was a triple. It would have made this problem a little bit less painful. Good. Okay, so A is 2 root 7. Cool. All right, let's work over here. Ooh, I spy a 45, 45, 90 triangle. I am given the hypotenuse. That is my x root 2. I know that when I'm looking for a leg, I divide by root 2. When I'm looking for a hypotenuse, I multiply by root 2. So I'm going to go off to the side. I'm going to divide this by root 2. Well, we're in luck because 14 is divisible by 2, which is beautiful. So this equals square root of 7. And remember, you can always check your answer. Square root of 7, square root of 7, square root of 7, square root of 2. Root 7, root 7, root 7, root 2. Anyways, it works out. Now we're trying to find x. And, ooh, I spy some like terms. There's lots of cool things in this problem. So maybe it was better that it wasn't a Pythagorean triple after all. Square root of 7 plus square root of 2 root 7, sorry. final answer, and some of you were typing it in the first few seconds. Good job.